Let's see how to perform analysis of a heat pipe. So heat pipe works on the evaporation condensation phenomenon. So this is a multiphase analysis. So to perform a multiphase analysis, you will need to create very high quality mesh, and you will need some other parameters as well. So we will see in this tutorial that how to create that. Here I have already created a model of the heat pipe. This surface will work as a heater, this will work as adiabatic wall, and this surface will work as a condenser. Here I have created only half of the geometry because my this face will work as a symmetry face, and by doing that I don't need much time for better analysis. So we will see now in the design modeler. In the design modeler, first step is to unfreeze this geometry, because we are going to slice this geometry into two halves. In the one half we will patch water only, and in the other half we will patch air, so that when we are doing analysis, the water will go from this water part to upper part, where there is already air. Remember that in which direction we need to give the gravity. Here in this case we are going to give gravity in the positive x direction, and that is 9.81. So here this part is water, this part is air, and how to separate these bodies, these steps are listed here. First you need to unfreeze this whole geometry, then create the plane at the middle of this geometry, and then slice this geometry by using slice by plane. Select that plane, and in the target all the bodies, and then create generate. So this body will be separated into two parts. Now next go to the meshing. So now in the meshing, create this named section. This part is heater, this part is condenser, this part, this face as a symmetry face, and generate the mesh as a fine mesh. I have already generated. This is not that much fine mesh that we need, but it is an okay quality mesh for this problem. You can create a high quality mesh as well, but this is just a tutorial, so it is okay. So now this problem is transient problem, and the gravity is 9.81 in the positive x direction. Now go to models. In the multi-phase we are going to perform this analysis with the VOF, that is volume of fluid method, because steam, air and the water, this all of these phases have separate boundaries. That is why we can perform this analysis with the use of volume of fluid method. Volume of fluid and body force formulation, there should be implicit body force, because by doing this we are focusing on the buoyancy force as well. You can perform this analysis by this boiling model and evaporation condensation model as well, but we are going to perform for the water only. That is why we can go with the volume of fluid method. Remember that number of Eulerian phases are three. One is for water liquid, one is for water gaseous, and another one is for air. Do not make mistake by giving these two phases. Now turn on the energy. Okay. Available. Okay. In the viscous, you can go with the laminar, but for the better analysis, I am going to go with K epsilon, enhanced wall treatment, thermal effect, and curvature correction. Okay. Now radiation is nothing. Go to materials, add water liquid and water vapor. Close, close. Now let's define the phases and the interaction between them. So our primary phase will be air, secondary phase is water, liquid, and tertiary is steam. Okay, now interaction. There are mass interaction between air, water, and the steam, that to evaporation condensation. So here the temperature is we are not going to give 373 Kelvin temperature for the evaporating. We will give only the just a second. Sorry for that. We will give 308 Kelvin, that is 35 degrees Celsius, because on the top, because we will reduce the pressure of the air in the air section, so that water can boil at the 35 degrees Celsius also. Surface tension, water and air will have surface tension of 0.072 SI units. Steam and water does not contain any surface tension, but steam and air also contains the same surface tension. We will give wall adhesion and jump adhesion as well. Blah, blah, and close. In the cell zone condition, here we will define operating conditions for that. So the pressure will be 4000 Pascal absolute only. This vacuum is created so that water can boil at 35 degrees Celsius. In the boundary condition, in the condensation wall, I am going to give a constant temperature of 298 Kelvin, that is 25 degrees Celsius, and the wall thickness of 0.005 meter, that is 0.5 mm. And on the heater part, I am going to give temperature of 353 Kelvin, and here also the same thickness for wall. Click OK. Now go to initialize this problem, and now we are going to patch our regions. So water and the volume fraction will be 1 in the water section, and the steam part in the air section, and the water section. In both the sections, the steam part is 0. Now click on patch, and now go to solution activities. Here you can give at how many time step intervals you want to save your iterations. Here I am going to give at every 20 time step iterations. Now go to run calculation. Here, due to this is multi-phase problem, this problem needs very small time steps. So after some experiments at these time steps, my solution will be converged, and I will have a proper result. Uh, Numbers of iteration you can give according to your machine. I can give this time step up to 2000, and maximum iteration up to 20 iteration is okay. And now calculate the problem. Guys, one thing I forgot to mention, that you will need to uh, export the quantities you require. So from this method you can select the which quantities you want it there. So we need of the volume fraction of air, water and steam. So here you go, volume fraction of air, volume fraction of water and volume fraction of steam. Click OK. And now again I will need to initialize, but you don't need that. Actually it was taking a lot of time to boil the water, so that is why we are going to heat up the temperature of the heater. So let us make that 393 Kelvin. Let's see. So now the calculations are done, and now let's see the results in CFD post. This is the CFD post, and for the results we will create a plane on the symmetry surface to and then we will see volume fractions of steam and water. Create the plane on the zx direction and the y a little below 0. So this plane is created. Now change the color these two variable. For variables, go to steam volume fraction and click apply. This is for the initial t equals to 0 timing. You can change the timing by clicking anywhere in the time step selector. Let us see time at points. Let's see steam fraction at time equals to 0.6 second. So as you can see, it is rising, rising, and again rising at very slow pace. And after sometimes you can see that after some time you will be able to see the water is also condensing on this part. So let's try to see that also. Steam water fraction. Now go to water volume fraction. Okay, right now we don't have water here because the steam has not started condensing. But after very long time or so, you can see the steam is also condensing in this part. So you will be able to see water in this part also. Now let's make video for that. Steam volume fraction, apply. Now go to here, time step animator, select this to 0 and save movie. I recordings, save it here, give appropriate AVI or anything you want. Options, white background, image size, full HD and 60 highest. You can create according whatever you want. Click on OK and repeat for once only and then click play, so it will save according to the time steps. And it is also, you can see the time step over here also, 250. So as you can see, the water is the steam is rising from this part, and you can see that the steam is rising from the surface part only, because first the surface is being heat up. So that is why you can see that. So as you can see, some steam parts are over here also, but after some time they are condensing, and so that is why they are disappearing from that part. Okay, I will be uploading new video every week, so subscribe and like this video if you like this video, and bye bye.